Thank you. Thank you for making time to actually come and listen to us. So, where are we, right?
Okay, the introductions again. I think Harold
Yeah.
already gave an introduction, but part of the thing is we wrote a book together. We used to, in my career, I've worked in San Francisco, New York, and now London. And while I was working in New York, Pierre and I worked for the same company, and it was a consulting company at the time. And we had an idea to write a book, which then I moved to London, and it took, I guess, we digressed for several years, but about a couple of years ago, we got together. And since then, for the last 3 years, I think we've been speaking almost weekly on these topics, which ended up with the book as well as this presentation. But actually, we just saw each other physically for the first time this morning. We've never presented together. We haven't choreographed anything, so, so bear with us while we go through this. But yeah, as Harold said, I work in Deutsche Bank as part of the Chief Data Office. I've done multiple roles in my career, some of them architecture, some of them not. I've managed platforms, managed teams, done consultancy, as well as worked as a software architect in some of those roles. So that's it on my side.
Yeah, thanks, Murat. So, Pierre, right? I live and work in Connecticut, and they say people in Connecticut have no accent, so I'm here to prove it, clearly. So in my role, I do a lot of architecture validations. Actually, it's a big part of what I do. And I was working with John Klein on a paper he's submitting, and as part of a query, kind of defining myself, he asked me how many validations I have done. And I tell you, you won't believe me, but if I really try to count, at this point, I probably have done north of 500 validations. It's just a lot. So what you're going to hear today is based a lot of our experience and try to reconcile two worlds which are very different. One is Agile. I spend a lot of time on that world nowadays, as well as architecture. So how do we do that? Okay. So we thought about putting together this kind of table of contents. I'm going to give you first some context, a few thoughts about what we think architecture is really about. And everybody, I'm sure, if we ask everyone your definition of architecture, you all have one, and that's fine. Okay. And then we're trying to answer the question, why do we want to even validate architectures? And then why do we even want to do that continuously? Validating is bad enough. Are you sure you want to do it again and again? I don't know. It's one of those things. And then how should we validate? And we listed three of the most popular methods we know of. The scenario-based approach, ETAM. For those of how many people actually have taken the ETAM course from VCI? Yeah. Okay. So definitely, if you haven't done so, please take it. It's a great course. Even if you're not going to use ETAM, it will give you a lot of food for thought. The decision-centric approach, this was introduced a few years back by a group of people, and it's called DCAR, D-C-A-R. I don't know how many people have heard of DCAR. So we'll tell you a little bit of DCAR. Interesting. And then the time owner checklist-driven approach, which is something that we still do as well. Okay. And then when do we validate? It's nice to say how we validate, but when should we do it? The answer, of course, is continuously, but what does that mean? Okay. And who should validate? Should we actually have a special team hidden in some place that's going to do all the validations? Okay. And then some observation and some ideas on how to go forward. Okay. Any other things that we should deal with today under this context, of course? Anything you have in mind that we should be able to answer? Yes.
Have you used any like executable architecture, discrete event simulators for evaluating the architectures?
Yes. So, but that absolutely. So let me write it down, because if I answer it now.
Oh, okay.
Yeah, it's better if we actually answer it when we. If not, we. So.
And that gives us time to think about the answer as well. It's a good trick,
Exactly.
We were consultants.
Exactly.
So.
Actually, if you remember the quote on the first page, the best validation, the real-time validation, the conundrum is you have to have written a system to get that validation, which is kind of, well, if you have written a system, it'd be too late to validate it. But yes. Any other thoughts, any other things that we should really try to deal with, if we have the answer, if not? Okay. So please interrupt. Okay, the whole idea of this session is to be interactive. So 90 minutes, we have plenty of time. So I mean, I certainly don't have, I have a lot of questions myself. Murat and I don't have all the answers, we're far from that, but we can at least try to give you some pointers. Okay?
So we'll talk about the context and a few thoughts about what do we mean by architecture. I found the keynote this morning quite interesting from that perspective that Calvin Henney gave. And there were about software is in the details. And I have two thoughts on that. One is a definition I like to use quite a lot about, well, two things. One is the Grady Bush definition of architecture. You know, the architecture is the sum of the decisions, architectural decisions made on a platform or something like that, which I paraphrased, I think is very key. I mean, again, we think that the unit of work of an architect is actually an architectural decision. So that's the key impact we're having. So the architecture is not the diagrams, it's not all the collateral you produce to describe, I guess, the system. It really is making the right decision so you can impact the system. Back to your, the question that's actually running in the production environment. So the architect's role is to make those decisions that can, at the end of the day, impact the production running system. So that was, I think, a key thing. The second thing I always like to think about an architect's role is to abstract at the correct level to make the decision they need to make at that point in time. So abstraction is very important, but you don't need to, and I find that conversation quite interesting about what Calvin talked about, high level versus low level versus the executables, etc. But I do believe architects do have to have the ability to abstract at the right level, because each decision you make is in a different context based on different stakeholders or different constraints you have at that moment. So those are just some thoughts on architecture. And then there's always for years I've said I'll try to talk about architecture without referring to real world architecture, and we failed on the first slide because we have the picture of the dancing house, which is a Frank Gehry and another architect's building in Prague. But there's always this thing of form and function, between those things, and that's a beautifully architected building, I guess depending on your style, but it's really. It's Fred Astaire and Ginger Rogers. That's what it's supposed to represent there, dancing together, wonderful building. If you go to Wikipedia 5 or 7 years ago, you can't find that anymore. Apparently there were lots of complaints of the people who lived in that building because of the air circulation, etc. So it all, again, depends on what is the architect's role. Is it to give such an image and leave an iconic building in Prague, or is it to make the people who live in it comfortable? So that's quite interesting. But that's just some thoughts on what do we mean by architecture. But for this talk, let's assume what we are validating is a system we are building, and we're at some phase in its development, and there's a bunch of architectural decisions we have to make and constraints we're living with. The interesting thing is that the basic tenets of good architecture have not changed. So a lot of the things, even in if you look, it was the 70s, I think, in the keynote that Calvin was referring to. And a lot of the topics, we talk, say, microservices today, but loosely coupled small components has been around for years and years. So really the basic tenets of a good architecture has not changed, I believe, in the last, if you read the Mythical Man Month, it almost describes exactly what we would, what we are living today.
Actually, that's a good question. How many people have actually read the Mythical Man Month? Good. Wow, if you haven't, please do. It's actually a very, very good book. For those of you who don't know, this is written by the architect of the IBM 360. And except one chapter, which is on hardware, we tell you how old the book was. It's amazing how accurate the book still is.
Yeah. So basically what we're saying is that, but what has changed, and I think that's what we're seeing a lot, and that's what we talk a lot about in continuous architecture, is that we can operate at a much larger technical scale than we could with the internet and the global infrastructure we have in a distributed manner, and there's the business desire for having, the quicker delivery timelines. That is the change. So I think the pressure of delivering at scale and speed is what's changed, but the basic tenets haven't really changed. What's always constant, and we talk about this a lot, is organizational hurdles and structures. Architecture, I think, again, was it Kelvin that mentioned it this morning? We all, like writers are really solo people, while architects work in development teams. We all work for organizations with teams which have their own politics and their organizational, I guess, hurdles, as we talk about, and those have not changed for quite a long time. So that's the context we're dealing with as architects and building architectures.
Okay, so going back to the topic, right? Why do we even want to validate? So we're just going to take you basically through and that's just a summary slide. So three reasons, right? Architecture, as we know, are the foundation of software systems. So if you get the foundation wrong, it's going to become hard to rebuild a house. Okay. Interestingly enough, how many people have heard of Conway's law? Mel Conway, right? You know, if you have heard of it, you know there's a strong relationship between the organization, actually communication structures of the organization, that's really what he said, and the design of your system. So you get a certain way of organizing a team, you're going to get a certain design, and there's no escaping that. So if you get basically 3 teams, front end, mid-tier, and back end, okay, you can guess the kind of system you're going to get. Front end, mid-tier, back end. It works every time. And you're going to have a lot of meetings and a lot of people talking about interfaces, which means a lot of problems, okay? So that's also one important thing of a validation architecture. And then the third one is really fixing defects early is really the best approach. The earliest to fix the defect, remember what Kevin said this morning, the length of time between when the idea is introduced and when the defect is basically found really is proportional to the cost of fixing it. So the more you wait, the more painful it gets. Very simple. Okay, and then I really like that one because really that's one thing that people forget. More than half our jobs is not technical. It's all about communication and collaboration. And that's a great way to actually encourage that. Very, very important. Okay. Okay, so foundation. Okay, so we kind of understand that if you get really an architecture which is carelessly or poorly assembled, one expression that always gives me kind of shivers is when I hear people saying architectures emerge. Okay, well, if you are very good at it, and some people are very good at it, you can actually afford to have your architecture emerging. Most of us, certainly me, I'm not good at it. Okay, so when I just rely on my instinct to get the architecture to emerge, the result is not pretty, and basically it doesn't end up well. So really getting the right foundation is absolutely critical. Okay, and then if you don't get the right foundation, what's going to happen is you're going to fail. Okay, one thing that runs absolutely, and this is where the ATAM class is important. One thing that the SCI will drill in your heads is architecture eventually are driven by quality attribute requirements, QARs. Okay, not by functional requirements. Functional requirements are the what. QARs are the how. And the whole point of an architecture is really to satisfy the QARs by making decisions. So the question becomes how do you link decisions and QARs somehow over time? Because remember what Kevin said, over time, a decision you made could be right today, something changes, it's wrong tomorrow. What do you deal with that? Okay? And of course, failures are going to occur at the worst possible time. Okay? We all enjoy getting pages at 1 o'clock in the morning, and it's enjoyable. Okay? When things in production. One of the best ways, by the way, to increase the quality, if you are worried about the quality of your systems, one of the best ways to increase quality is to get the developers to support in production. That's the best way. And that's a technique used by every company I speak to on the West Coast. That's definitely best practice. We don't always practice that. Some of us, including travelers, we tend to have separate production support groups. The results quality goes down.
I'll give an example on it's interesting when we were talking with Pierre this morning, and an incident I lived with in production occurred to me, and the ultimate validation is in production, and something I lived years ago when I was responsible for some of the systems that communicated between the organization I was working for and external clients. We had a major upgrade to the platform, and we had tested and retested and done everything. And we went live, and it's not working, right? And this is production, right? So none of the clients, are receiving any communication from us. It's a very stressful moment. At least at that point, actually, my organization, we do severity 1, 2, and 3 incidents. Then I learned there was actually a severity critical incident, which was even above them. And I had to live through that for about 32 hours with me and the whole team not sleeping. And basically, what had happened is that there was an old certificate in the production environment. The security certificate is sitting there in the directory. The old version of the software ignored it, just picked up the most recent one. The new version of the software got confused. It says there's 2 certificates, I don't know which one is real, and that was the whole reason. And if someone hadn't found that out, we were under constant pressure to roll back. If someone hadn't found that out by some, I don't know how he did it or what happened, and once we found it out, the fix happened, and actually in 30 seconds we were able to turn the whole system around. I probably would have lost my job, because what would have happened? We would have rolled it back. We would have gone through months and months and months, again, retesting, validation. Are we sure? Maybe build another environment. We would have deployed the same code with our production, that thing, certificate is still living in the production environment. So it's a very, and I think that's why, I think the trend towards, I think there was a Docker thing earlier today about controlling your environments as well as your code is very important, but we do live in very complex systems, and certain things you only find out when you go into production. So you have to, the speech given earlier today was very interesting about failures, and he said the only thing you can control in a failure is how you react to it. Everything else, no matter how much prep you do, and actually we're going to say lots of nice things about architecture validation, what you can do, things will go wrong at some point. That's just, I think, the nature of the industry we live in.
Cool.
So we said there were 3 things of why we do architectural validation. And the other thing about doing the validation is an interesting, twist on it. Is we're also, validating, we're checking or testing the team we have building the system. So the Conway's law says it's basically organizations that design systems are, I'm not sure the exact word, it's written down somewhere, are constrained to basically mirror the communication structures they have of that organization in their design. So basically, if you ask, if you put 2 teams together to build a system, and then you put 3 teams together to build the same system, one will come up with 2 components, the other will come up with 3 components. So Conway wrote that article in the 60s, not particularly focused just on software, but that's I think, a very important law to be aware of while you're building software in general. And about, poorly organized team will result in a poorly designed architecture. And it's very interesting that in a validation session, you will get to see those inconsistencies in communication. I think, again, Calvin was mentioning he could draw his architectural boundaries of where people disagreed on, which is kind of an interesting topic this morning, or interesting thought. But again, while you're doing the validation sessions, you're also checking, or at least you're getting feedback, is my team structured correctly? Is there something inherently wrong about the way we structure this project, this team, that's resulting in either miscommunication during the validation session or just the architecture not hanging together?
I mean, one certainly, I'm not going to create a Pierre's law, but one indicator of a poorly designed system is how many meetings you have. Too many meetings actually an indication that something is wrong, because you have issues communicating. If you have issues communicating, something is going to go wrong somewhere in your design, guaranteed. That's so almost the goal is to have no meetings, if you can. Okay, so that's kind of a third reason why not fix defects early. It's kind of tongue-in-cheek, because of course everybody wants to fix defects early. Actually, if nothing else, think of defects as being double waste. One item of waste is it takes energy to create them. It takes even more energy to fix them. So you actually, why not try to eradicate defects? Nice goal. So definitely try to validate as early as possible. Creates a lot of economic sense, because you're going to find a lot of defects, and fixing them won't cost you too much. It won't be the cost. Okay. It's also going to be less painful, less stressful, because production is really not fun fixing defects there. Okay. The one thing also that we found out through experience and doing a lot of reviews is the more finished the system is, the more code you have, the more attached people becomes to their code and to a system. This becomes like, have you ever tried to tell someone their baby is ugly? Same thing. Okay, the consequences are dire and very bad. So if you wait long enough, basically validation becomes almost impossible. So the idea is to try to validate as early as possible and get into the cadence of validations. So people really feel validation is not something done by some kind of group that's being sent upon them to audit them, but it's also being done by, really it's a collaborative effort. We're all the same boat and we're all trying to make the process better. Okay.
So another, I guess, reason or to do the architecture validations is around communication. Again, the softer side of the technology world. When we worked together, Pierre and I, we had a boss who said, more architecture is 50% communication than collaboration, 50% actually doing the work. I think at least Pierre believes it's actually communication and collaboration is more than 50% of that.
Yeah.
So there's interesting things about that. Pierre, how can validations help in communication? One important thing is how you, of course, every organization is different, but how you culturally, what environment do you set in doing that? So if you have a central group, because validation or reviews has this implication that there's a central group that's coming there, almost criticizing you and, taking you through a checklist and asking you all the difficult questions, I think that would have failed. Well, the way we like to see it is that just like pair programming is a very powerful paradigm, the review should be culturally, the better approach is to have it as a more peer reviews and peers reviewing each other and critiquing each other and providing input is very important. And that's why people making decisions actually get to talk to other people about the decisions they're making and their architecture, and they get more input into that. The second more important part is also, or equally important part is I think in large organizations, which both Pierre and I work for, there's a big challenge in communication across the board. There's lots of teams work in different silos and they talk different languages and then they just don't collaborate very well with each other. So one is if you do institute this peer review structure, what you have is you as an architect on one team or just a developer or anyone in one team get to see what the other projects are doing and they get to talk to you. So by nature, you increase the collaboration within the organization. Secondarily, if you're actually a little more structured about how you do your validations and there's ways of documenting them, sharing that knowledge, that's a huge value for the organization. The amount of decisions and similar decisions people have to make in mid to large size organizations not aware of what other people have thought through is huge. So anything that helps with that communication and collaboration between teams is very important, and we believe validations do so as well.
So comes the continuous part, okay? Because so far what we have said, we could have said that 20 years ago, 30 years ago, yes, validating architecture, probably a good idea. But now, why do we validate continuously? So, well, that's the world I live in, at least, okay? So most of those things didn't even exist a year ago, okay? Blockchain, we didn't deal with blockchain a year ago, now we deal with that, okay? Gamification, yeah, we're dealing with that, at least in my space, which is insurance. We have been dealing with that for a while. Internet of Things, it's really going fast upon us. Autonomous vehicles, where travelers is about one big line of business is insuring cars. So autonomous vehicles is very, very impactful to us. Bitcoin comes with blockchain, smart cars, 3D printing has been around, robotics, big push for robotics, okay? AI is kind of a return of AI. Actually, I don't know at this point how many returns AI has had. I'm old enough to remember when AI first emerged, probably 40 years ago, and died and came back again, kind of a zombie 20 years ago, and it's coming back again. So, but in the meantime, it's there, okay? Smart homes, cloud computing, so on. So the message here is things change at a very rapid pace, and they actually change faster and faster now. And the challenge is our architecture needs to change as well. So how do we do that? That's really the goal. Does that resonate with anybody? I hope I'm not the only one having those issues, but that's basically, and we really need to evolve continuously. Now, one little bit of good news, because this is kind of a bad news slide, a bit of good news is if you actually do continuous reviews, continuous validations, the time you spend on each validation gets shorter and shorter. Because it's really hard when you do a validation session to assemble a large peer review group for a day or even half a day, okay? The best we can do nowadays, maybe 2 hours, people don't have time. Okay, so you actually, by validating several times, you actually decrease the time it takes to validate. We'll see that in detail, but actually an interesting finding. Okay.
So this we're going to give our approach continuous architecture. This is just a little summary of the 6 principles it's based on. But we believe that software architecture is the whole reason we call the approach continuous architecture, and is really the fact that we want the software architects to evolve continuously and not be very discrete steps in the technology lifecycle. And this is just a quick run through our 6 principles that underpin the approach. And I won't go into too much detail on them because we just want to focus on the architecture validation concept. But our first principle is that we should be architecting products and not just solutions for projects. Again, anyone in the agile world will agree with that. And you should think of the things you're dealing with. What product am I giving to the business? Have product managers that are just as empowered as architects and team leads, and really try to have a more long-lived, life cycle of the technology rather than individual project-based decisions. The second principle is focus on quality attributes, not on functional requirements. I mean, the premise here being that you could probably have multiple architectures that meet your functional requirements, but there's probably very few that can meet your quality attributes, or as some people call them, the non-functional requirements. And we'll be talking much more about utility trees and then how to use them later on. Our third principles, again, which comes back to the delayed design decisions, is related to the agile world, is delay design decisions until they are absolutely necessary. So you really want to make decisions. And I think Calvin mentioned to that this morning as well. You just want to have the facts to be able to make a decision and not just jump to making all the architectural decisions on day number 1. Our fourth principle is, the architect for change, leverage the power of small. We already talked about, microservices, loosely coupled components, etc. That's obviously a key principle that any architect should follow. Our fifth principle, which is getting more and more prominence, but less so traditionally, is that you architect for build, test, and deploy. What that means is that the architect is not just go back 10, 20 years, and the architect will come in and say, hey guys, here's the wonderful architecture, good luck with development and testing, and let me know if there are any problems, and disappear. The premise here is the architect is also responsible for the architecture of the test and deployment environments, especially with things like the cloud and containers, etc. That's becoming even more important. So you should architect not only for your environment, but how you build, test, and deploy your product. And our final principle is just be aware of Conway's law. Yeah, it's a difficult one. We can spend a whole nother session on this, but basically model the organization after the design of the system. We really struggled in naming this principle, but it really is about being aware of the communication structures your organization have and you set up in your team. Question?
So I was just curious on number 5, was there a reason why you pulled test out of the agile on the sprint iterations for that? Because that seems to me that implies that you would have an iteration that would be considered
diagram there.
In the diagram.
Actually, that's the diagram there's a before and after diagram, and this was, I think, in our graphics to set this up. So there was no reason for that. You're right. Test should be part of it. So this is the, before you had continuous delivery, this is what the things would look like. So this is the pre-continuous delivery and post-continuous delivery. There's another diagram. We just picked this one for.
Yeah, this is one slide out of the 30-slide presentation somehow. The reason why I really like those 6, if we go back to the 6th one, I really like those 6 principles. Beside the fact is I use them in the architecture validation as almost an internal checklist. And when I look at an architecture, even nowadays, and I say, let me see, did the architect products? They look like even language tells you something. They keep on talking project. Okay, they probably have a product manager. That's good, but they keep on talking projects. That's a bit of a problem. The next question is: is a product manager really empowered to make decisions? If the answer is no, as it is unfortunately most of the cases, well, you have someone called a product manager, fantastic, who probably yesterday was a project manager, so he changed the label, but they haven't really achieved anything. So to me, that's the first warning signal. Okay, Did they focus on quality attributes? Do they even have a list of quality attributes? Did they even think of prioritizing? Do they have a utility tree? Okay. Did they make decisions when they need to, or did they just make decisions just in case? You know, someone said that the system was supposed to handle 100,000 transactions a second. Fantastic. Okay. They don't even expect to go there until 10 years from now. Why bother? Okay. Did they actually went and basically try to leverage power small? Did they design for change? Are they anticipating change? Don't know. Okay. Did they care about anything beyond basically building? A good question as well. And are they actually, how is their organization? So they give me a quick checklist, and I'm able to actually very quickly kind of predict whether we're going to have problems or not. Kind of useful. The case study. So basically, we're going to play a little game. We're going to pretend that we are basically, and this is very highly sanitized. We'll probably give you some more details as we speak. But we say, okay, we are an IT group in a large corporation. Think Travelers, think Deutsche Bank, and so on and so forth. And we've been asked to build a new mobile system to allow prospective customers to do price comparison to purchase products. Okay, and my little team assume that they're going to use Extreme Agile. Okay, assume that they're going to do basically pair programming. Assume that they're going to basically they want to do TDD, continuous delivery, and somehow, don't ask me why, they also want to do architecture validation. So what happens? I mean, interesting situation. Okay. Okay, the first question that the team is going to ask themselves is, what the hell is an architecture validation? Okay, what do we mean by even that? How do you get started? So the first thing they're going to find out very quickly, or we're going to find out because we are the team now, is you need an approach and some rules. You can't do architecture validation by the seat of your pants. That doesn't work. And honestly, best practice, write the rules down, preferably on a piece of paper, and hang it in a room where you actually work. So at least everybody, when they do a validation, has a visual on those validations, and they can work by the rules. If you don't do that, you basically create something which is not a process, just very, very disconvoluted thing. Okay? So the team has to be inclusive. Okay? Do not turn off anyone when you do validation. That's very, very important. Okay? Do not turn away, I'm sorry. Do not basically say, well, sorry, you're an architect. Don't. That's fine. You know, involve non-architects as well. The more people you involve, the more point of view, the more diversity, the better. It's actually, you are after trying to get as many point of view as possible, because people are going to come with questions. The idea is not to have the answers, it's to come with questions that get you to think about what might happen. Very important. Okay? And I think the big, big benefit is as you start doing this validation, as you start learning, you can really create some kind, think of a learning hospital. Okay? You create a learning organization, and people start learning from each of their experiences, yes, from mistakes as well, and hopefully they don't make the same mistakes. They create new mistakes, which is interesting, but they don't make the same mistakes. And you actually get the organization progress a little bit. Okay.
So again, I mean, it's a little bit of repeating what we said earlier, but the key things the team has to answer is, you know, look at, you know, the key elements we're looking at the architectures. The first one is, you know, do we have the right architecture to meet the quality attribute requirements? Has it been addressed? So can we actually say if it's performance, and we'll give some examples later on, or if it's configurability, whatever it is, do we have the architecture to meet those requirements? And it's important that the team itself is viewing, so again, back to what we said again, validation is not about someone externally coming in and you know, just grilling the team. It's really about making sure the team itself understands the why they need the architecture to be validated. The second thing is that is the design decisions, and we've talked about that before. Again, the design decision is you know, I believe, the unit of work of an architect. So have we been able to map our design decisions to, first of all, to our quality attribute requirements, as well as to our wider requirements? Are we making the right decisions? And most importantly, do those decisions have dependencies on other decisions? So that's another key thing to to deal with. And finally, the team, as we've said that before, has to believe that collaboratively we can get to a better place rather than just steamrolling in basically a very project delivery focused approach.
And this typically occurs when the team starts kind of getting into issues here. You can tell, okay. So they have some questions about. So, for example, you're going to see one of their QARs is modifiability. What do we actually mean by modifiability? Modifiability could mean anything to a lot of people. How do you measure modifiability? Is my system really modifiable? I don't know. What they know is someone told them, your system, your mobile shopping system better be modifiable because we don't know what we want right now. Okay, so you better make sure that it's modifiable. Scratch, scratch, scratch. How do I do that? I don't really know. What I do know is if I make a mistake, the cost of repairing that mistake is going to be expensive. So I'm kind of painting myself in the corner more and more. So hence, so also keep in mind, decisions are what this is about. Okay, at the end of the day, our architecture exists. It's a set of decisions. Nice diagrams, so on and so forth, but the ultimate work product is a decision. So are my decisions really linked to my quality attributes? I don't know. Don't know yet. So lots of questions here. Okay, so here comes the crux. I love that slide because that's really the fun. So the team, basically, what the team did is they used the usual technique. I'm going to go and see Mr. User, okay? And I'm going to say, what do you think the question is? What do you want? Okay, tell me what I want and I bring it to you. Well, something funny happens at this point. Any human being, or most human beings, when you go and see them with a blank piece of paper, you're going to get a blank stare. I don't know. Okay, we're trying to build a system that nobody has seen before. Okay, and by the way, this happens more and more as we move into what's known as a digital age. Okay, we're asking people to predict things that they don't know. I mean, if you ask someone to modify an accounting system, most accountants can actually give you, okay, here's what I need. Okay, if you ask someone to say, well, you know what, I'm going to have an IoT device. What the hell is an IoT device to start with? Okay, communicate with blockchain. What do you mean a blockchain? I don't even know what that is. Okay, you basically lose people very quickly. Okay, so we have a problem. Okay, no matter how much you are good at use cases, user stories, and a thing, if people can't tell you even an idea of what they want, you're stuck. Okay, that's why basically, and startups have been having that issue again and again and again for the last, I think, 10 years at this point. Okay, when you're a startup, you have no time and no money, guaranteed. So what do you do to solve problems? Well, you come up with a minimum viable product, something you can get into market quickly, because again, you have no time, no money. That's to be quick. Okay, so if you can get into market quickly to get feedback, because that feedback is actually going to get you a requirement. So the whole requirement process, which is changing on its head, instead of asking someone, the happy days we could ask someone, Harald, please tell me what your requirements are. Can't do that anymore. Now you have to have some ideas. You have to test something. I think that what Harald needs, and put it in market quickly, get feedback, which means you have to deploy quickly, and that's very important. So interestingly enough, the MVP, oddly enough, is now getting a little bit, not long in the tooth, but so one thing with travelers. Okay, we are a bunch of perfectionists. We love perfectionist travelers. The problem is, if you're a perfectionist, the minimum viable product is probably very quickly going to turn into a maximum viable product. Ouch. That's not what I wanted. Okay? So more and more, our MVPs turn into this long list of features. Okay, Murat wants a feature, I want a feature, and you know what? We're going to see who's going to win. Well, most of the time, well, we leave both features. Well, the problem with that is now, again, we're back to the long list of products. Okay, so comes the idea, a couple of ideas that we put. One is the RAT, and actually, when you get the slides, you see this is an actual link, RAT, the riskiest assumption testing. So what this says is, okay, so if I'm creating any kind of system, I'm going to have a list of assumptions. Some of those assumptions are going to be riskier than others. Okay, so if those assumptions prove wrong, then the whole thing falls apart. My whole architecture, my whole foundation is dead. So what I do at this point, I'm going to do my best to test my riskiest assumption. And that could be done with code, or could be done with a focus group. There are many ways to do that. That's right. Another company I work a lot with came up with a slightly different version of that, which is really based on, and I forget his name, the guy who started LinkedIn. He's credited having said that if you basically not embarrassed with your first shipment, you're shipping too late. You should be embarrassed by your first shipment. So how many people are normally embarrassed with what they ship? I didn't think so. But that's the goal. So we ended up coining the kind of acronym SVP for shortest viable product, or it's actually a rudest version of that, which I won't repeat. But basically, the idea is really to come up with something which is unfinished. The keyword is unfinished. By the way, there's some kind of architecture underlying this. MVA, minimum viable architecture, or SVA, shortest viable architecture. The idea is to have an unfinished architecture, something that is still based on QARs, still based on decision, but at least you don't let it emerge. You're in control. The keyword is in control of your architecture. If you don't, architecture will happen. You always have an architecture. The question is whether you want to control it, or whether it's going to control you. Make sense? Has anybody in this room experimented with MVP? Nobody? Please. What's your experience?
I think I share your experience that usually the MVP is too extensive. So you ship too late because you're not able to be embarrassed.
Exactly.
And especially in large corporations, I think this happens because you have too much money and too much time. And that makes you ship your MVP too late.
I agree. I mean, my job, one of my jobs as travelers is to remind people who have too much money, too much time. I keep on telling people, if you're a startup, okay, you'll have no money, no time. How would you solve this? You still have to solve a problem. How do you solve it? Startups do that. A good example, I'm sure most of you use Gmail, right? Gmail was created as an MVP. There are still irritating features in Gmail. Okay, you have on your left side, you have to expand the folders every time. That was MVP. People say, well, no, that's not, having a complete list of folders every time is not something you need to have. You have to have. The question is, when you use a feature, is do I really have to have it? And you have to ask yourself, because if I go and ask my business partners, of course I have to have it, Pierre. What is it about? I have to have it. But it's not important. What's important is feedback. You're after validation. And feedback is validation. That whole concept of eliciting continuous customer feedback and updating MVP, that's what you're after. Okay? Because back to your question initially, okay, you want to test the executable architecture, but you don't want to build a whole architecture to test it. So you have to build in small segments and put it in, get the feedback, and then that's actually the test. The question is, the feedback can be very uncomfortable at times. People may get upset sometimes, so get upset. Yes. So a lot of things, and actually Murat, you probably know more about that because Murat used, this little thing as I told you, he used to work for Rational Rose at some point. Okay. For Rational.
So am I supposed to say so? No, but
oh, sorry, I put
no, but I mean that's a very interesting topic about. So I was, what was it about? About 6 months ago, I presented at Go to London, which is a developers conference. And actually, the average age group of the audience, I mean, I didn't ask, but looked like between 25 and 30, right? That's what it was. And there were a bunch, and they're all developers, actually. It's a developer conference, and they had an architecture track. And what came as a shock to me in that audience, when the person presenting asked how many people use UML, only 2 hands went up, which one was mine. So,
and you were so plenty.
So, I'll take a slight tangent here, but it was very interesting. And lots of the people presenting were, one of the presenters said, was actually his tagline, the 1990s are calling, they want their models back. And it was an interesting observation about how the software industry in general is, first of all, it's not a trade, like anyone can be a software developer. It's not like you have to, going to schools or going to maybe the SCI bootcamp might make me feel more qualified, but in all honesty, for lots of organizations and lots of startups, it doesn't matter. Anyone who can write code is a developer. And, it's not like doctors train the next generation or things like that. So there's lots of things, and it's a hugely growing population, and it's a very young population, and they relearn a lot of things that have been, as we said, constant. And one thing that seems to have kind of, I thought, I was there when UML was born, and I thought that is one of the big successes because it's all about common language. And that was very important in defining your architecture. And what seems to have happened is that something happened in the last 10 years where that common language is not as common as at least I thought it was. So that's, but I believe that modeling is very important, basically, and having a common language to model is important. No.
Discrete event simulations, there's all sorts of things that are a little bit higher level than just code, you know?
But I guess it's an interesting one. I'd be interested in Pierre's views about that. And I haven't used a lot of those tools, just to be open, but my view is that the level of effort that might require, it's all a cost trade-off thing, because I think just getting and doing a minimal viable architecture and writing some code to test some of your rats, as they said there, is probably better time for money rather than invest, that would be, but I'm open to other ideas. Again, we don't have all the answers, but it's a very interesting topic about, how much do you want to invest in tools to simulate? And it's also depending on the field you're in, because both Pierre and I operate in commercial large enterprises that are different than if you're dealing with, if you're in robotics, and I've read a few articles on robotics testing, there's a very different approach, which is much more structured and I think aligned to what you're doing. If you're actually building air traffic control systems or things like that, it's very different. So our personal experiences come from a world of commercial software for large organizations where if things go, you're really testing the consumer feedback, et cetera, or maybe internet startups versus mission critical systems. So I think that's a very good,
it really depends on what you're doing, right? So most of modeling nowadays, at least where I work, occurs on whiteboard. And we don't even bother to put in a tool anymore. We just take a picture and add to the computation. And it's kind of extreme, but we kind of tend to do that. Now, there's also, I also have AI groups working for me and robotics group. And as Murat said, they tend to be a little bit more, it's a different kind of work. It's a different kind of, AI, you spend a lot of time training the model. The models are not that difficult. Actually, most of the models are open source. They're publicly basically published. The difference is really the data. The companies which are tops in AI right now, they are the data companies. Amazon, Google, and Microsoft. Those are the three companies which are absolutely top. And they are the ones who have the most data. Microsoft has every piece of data you can imagine, especially LinkedIn now, on top of that. Google, of course they do. And of course, Amazon, anything we buy. And those are people who are really tops. They do a lot of really testing the model, and training the model is part of the job. Writing the model is a small part. So the whole almost, that's why I keep on saying AI is going to be, if it happens, big if, because I'm old enough to have seen AI coming and going a few times. But if it happens, it's going to be the largest revolution that's going to hit us on two grounds. Number one, the skills we have are going to have to be totally different. So we better all go and brush off on statistics quickly. And for example, I have two people in my group. One is an ex-astrophysicist, or she's still an astrophysicist. The other one is a neuroscientist. And they are, in my IT group, they are in the architecture group. That's the disruptive technology part. So the skills are very different. And the process is very different too. So that's going to change a lot what we're doing. But if we want to talk about traditional IT, which kind of we're talking about today, even the modeling is getting more and more informal. It's my observation. Now, is that a good thing or bad thing? I don't think it's a good thing personally, but that's what it is. I can't stand in the way of trial. I can, but I get flat.
But one thing we don't invest in enough, at least in most organizations, is really proper test harnesses and proper testing. And that is the big thing. So it doesn't matter if you buy an external tool to help you, but if you have a proper test harness, you could actually, for your product, you can test your architectures much more quickly and different options with real code or with certain stubs and things like that. But test harnesses and test data is I personally see from where I sit a huge gap, which is such a lack of investment in that area. And not having that is going back to principle 5, you know, architect for test as well as for other things. Not having that actually inhibits your ability to validate effectively as well.
Okay, so what about minimum viable architecture? So power small, right? So in the 70s, and we all have this idea, and I forgot who gave me those three terms. I mean, it may have been a gentleman from IBM. So this was the year of spaghetti, or the years of spaghetti, right? We had systems that look, and some of them, at least the travelers, we still have them. They were built in the 70s. We have some like these. And it's scary because the hardware changed. You know, would you drive today, basically, today's car with a 1950 set of tires? So you wouldn't do that, right? Yet we do that every day because we have our mainframes, which are actually a mainframe is a modern machine running 1970 code. Okay. Problem with that thing was a cat couldn't find her kittens in this. It was try to change something and you start something and you just hide. So came the lasagna, okay, the layer architecture. Okay, lasagna sounds good until you eat it and kind of stays on your kind of stomach. So now at least you know where things are. Things have moved nicely, okay, but try to take a brick out or a stone out and run again, same problem. So basically not very resilient to change. And now we move into the ravioli. Clearly, when I did that slide, this was before lunch. I had something on my mind. And you know, I kind of tried very much to do a presentation without using the M word, without using microservices, but I failed basically because at the end of the day, it really doesn't matter what you call what's at the bottom. The bottom, it's really a 1970 concept. Yes, it's some of us you remember that 1970 concept of loose coupling. Okay, if you basically, and this is microservices are really at the essence, it's share nothing, loose coupling all over again. Okay, if you loosely couple your components, you'll be able to go fast, which is the whole idea. Okay, if you tightly couple, you won't go fast because every time you change something, you have to pull the whole thing. Okay, so if you remember one thing of this presentation, look for for loosely coupled components, or if you look for problems, you look for tightly coupled components. And of course, this is my favorite, the BARF, right? I kind of talk about the BARF, the big architecture up front. Try, you know, if you think minimum viable architectures, okay, try to think, don't try to architect something you don't know yet, because you don't really know what's going to happen. When I do an architecture review, I get very, very worried when people start telling me, oh, we just did that just in case. I say, God, here we go again. Okay, just in case of what? Of one thing happening out of, the probability may be 1 out of, I don't know, 1 million, and you really worry about that? But that's what people do. They want to give these big upfront architectures that are just in case they can handle, well, handle something that may never happen, but at least they could handle it if that's the case. Okay. So let's go back to a little bit of basically tools.
Yeah, I mean, we've spoken about, so far we've been talking about architecture validation, but I've not told you, you know, how to do it, or I haven't spoken about how to do it. As we said, even the wording I had said there was incorrect, because this is a bunch of ideas. Some might work for you, some work for us, some don't. And so now we want to actually talk about the tools. So the most important thing is the concept of utility trees, which Pierre will talk about on the next slide. But as we said, this is just a summary slide. In summary, there's 3 approaches that we see in the industry about architecture validation. And that's scenario-based, decision-driven, and checklist. So we'll be talking about each one of those very briefly, kind of a little theoretical background, then we'll come back to and show how those could be applied to the example Pierre gave. And final note is basically, as we said, customer feedback is the best tool. You know, everything we're doing is in some way I guess, in place of that.
Basically, the paradox is if you can build it and get validation, it's perfect, except if it's wrong, then you have to build it again. But, okay, so full disclosure, I am not being paid by SEI to discuss that slide. I personally love utility trees. I think they work very, very well. And I think I was first exposed to them 10 years ago. They're just absolutely great. So basically, a utility tree, I guess next, because there's some animation. So you start, oops, a little bit too fast, man. Just stop. Okay, so you start by basically putting all your quality attributes. Okay, so all the ones you know of, okay, usually we limit ourselves to 10 because beyond 10, it starts getting ugly. By the way, I use a mind map, a tool to do that, which is neat tool. I've seen people using all kind of tools. Whatever you do, so you can use PowerPoint as well. The point of PowerPoint is if you have to change it, you have to redo it. Pain in the neck. Well, my map tool you can do easily. So the idea is you list your quality attributes and you try to order them if you can. Okay, if you know priorities, you order them. And then the next thing, okay, is refinement. Because if you look at something like performance, well, performance is great, but what do I mean by performance? Could be basically batch, could be real time, I don't even know. Okay, and the next one is really, so basically, this is all great to refine quality attribute, but how do I measure it? If I can't measure it, I can't test it. If I can't test it, how do I know I made it or not? Okay, so far, so the whole idea, and it's not a full, if you are familiar with ETAM has a little bit more than that. I use stimulus, response, and measurement for each scenario. Works for me. I mean, they have two more, I even forgot where they are, but those three work for me very well. And by the way, you don't have to basically explicitly go down to scenario for every quality attribute, just the most important ones. Okay. Now here comes the secret sauce. Okay. We found out, review after review, you can actually link the quality attributes to the decisions. Ta-dam! Because at this point, that's a hard moment. Because at this point now, I have a chain that links my architecture decisions back to quality attributes, which is exactly what I was trying to do. So now I can measure the impact of a decision on quality attributes. And now you understand why travelers have a bad reputation of basically absolutely insisting that every team that comes with the architecture validation has this diagram. Because this allows us to immediately understand what's going on. It's actually a simple thing. Again, if you only remember one thing, remember that diagram. It's a simple thing, doesn't take long to do. So it clarifies your mind because suddenly now you can see how you end up in a decision as opposed to I put a decision in a hat. Okay, makes sense? I mean, you guys follow? Yes, no? How many people actually use utility trees? Good. Excellent. Good. Sorry. Never mind. Okay. Okay, so ETAM. Okay, so very quickly, the idea is ETAM is the scenario-based approach, architecture trade-off analysis methodology. And the idea is really to look. Click next. Okay, the idea is to look for trade-offs. That's really the whole thing at ETAM. So every architecture has trade-offs. Okay, whether we like it or not, make a trade-off. For example, if your utility says, for example, security, okay, Terry Semia works for me. He's my chief security architect here, so I can actually use security. Security and say performance, okay? Usually I have some kind of trade-off. Security or performance and usability, that's usually a trade-off, okay? I get very nervous when people basically, number one, can't talk about the trade-offs. And number two, have utility trees, and I've seen it. Well, with security, I've seen that. And then they say, well, Pierre, security is implied. I say, if it's implied, why don't you write it down? Okay? And I've even seen cases where performance is not in there. So you really don't care whether your system is performing or not. You serious about that? So in this case, back to our little case study, basically, in this case, this is what they listed, the web short quality attributes. And in that case, security was first, then performance, configurability, and so on and so forth. Okay? And the idea is we test the whole thing, and I'm doing a bad rendition of ETAM because that's a class that takes 2 days. Okay, but we basically the idea is to test the architecture against scenarios which are associated with quality attributes requirement of the system. So basically test the architecture with scenarios. Okay, it's a great methodology. I love it. The only problem, it takes time. Okay, a typical ETAM session can take typically, so SCI recommends I think 2 days, okay? Minimum 1 day. It's shorter than 1 day, it's really hard. And it's hard to get people in a room for 1 day. Okay?
So
decisions.
Again, yeah, so we said there were 3 approaches. So Pierre spoke about scenario-based approach. There's also a decision-driven approach. There's a formal one, DCAR, Decision Centric Architecture Reviews. And if you search for it, you can get it on the web. But here, actually, rather than validating the scenarios, you're actually validating the architecture. So you basically, systematically review the architectural decisions made by the project team. So it takes less time than a scenario-driven approach, and it requires less training. But of course, it requires someone to be able to define their architectural decisions in a consistent manner. What's also nice is what Pierre talked about, is to be able to connect them to the quality attributes, as we talked about in the utility trees, is quite important, which is just what that helpful hint said. The important thing in that approach, what's interesting is, and here's an example of basically saying, is that decisions on their own are important. What I find quite interesting is how decisions interrelate with each other and their connectivity. So there's something called the decision relationship diagram. This is a very simple example of, basically saying, you need 24/7 deployments because you need to have champion challenger testing. It's an always on mobile site. Again, the example we were given is around the mobile site, which means you need 24/7 database availability. So again, these are some decisions on why did we end up with a dedicated infrastructure for this platform versus using a shared infrastructure could be driven, and you could see the connections between decisions. But again, this is the second approach. Then we have the more traditional approach, which is the checklist-driven architecture. So here, basically what you do is it's checklists, right? Everyone loves checklists. You go through them and you just validate if the team has met the checklist approach. It's good because it's a very quick and easy way to do it. Everyone knows what a checklist is. Everyone knows how to answer the responses. So you can do it very quickly. The problem with it is that it goes back to, again, it's the antithesis of what we wanted to say, of being a more collaborative, engaging thing. It really ends up being, once you have a checklist, it means you feel like you're being, even if it's your own checklist, it's like being, judged by some central authority. So that's something.
The police interrogation.
Yeah, exactly. Now, to do the checklist, we can use as Pierre said, you can use several different techniques. One technique we like to use is just based on the principles we outlined a moment ago. And again, or you can do your checklist against the utility trees. So again, there's multiple approaches to how you can do checklists, but at the end of the day, it's a bunch of questions and you answer them. We find, and Pierre will talk about that more in the next approach, a good place to use the checklist is where things are a little more stable. It's more, when we said we're continuously evaluating, again, we don't want to use each of these approaches independently. You want to use them in some combination. And the checklist-driven approach is more approached in the more mature cycles of software delivery.
So before you leave that slide, very important to kind of, if you like checklist, there's a great book called Checklist Manifesto, written by SATURN. Absolutely fantastic book, and I just put the link there on Amazon. It's something, it will tell you a lot, but a very easy book to read, a small book. You will do two things. Number one, if that book doesn't make you love checklists, I don't know what will. And number two, you'll be scared of going to the hospital again. That's because oddly enough, so more and more hospitals have discovered the power of checklist. I mean, pilots knew the power of checklist for a long time. I don't know if you guys know, but basically, when you're on a fly plane and you are in a dangerous situation about to crash, the first thing you do is check your checklist. Even if you are in a very life-threatening urgent, they are trained to check their checklist always. I tell you something. At some point, the hospital had stopped using checklists, and funny thing happened. Surgeons, for example, forgot to wash their hands before doing an operation. So that wasn't too good, especially with patient. So checklists are becoming now absolutely mandatory in every hospital. And that book is fantastic. I cannot say enough over that book. And a good thing to remember with this presentation. Okay, so back to our team. So remember, I have an agile team, pairing and so on and so forth. Now, the fact they are pairing already involves a level of quality. Okay, they are doing test-driven development, which means they write the test first before they write the code. Another great practice, by the way. It's hard. Actually, we have a saying that says nowadays that coding is easy. Testing is hard, because writing a test is hard, okay? And they also do continuous delivery. So how does it get together? Well, the first thing when it started, again, this is an example. This is actually an actual life example. What works for us doesn't mean that it's going to work every time, but should give you some ideas. So initial validation, okay, when you have a little bit of an architecture, but not too much. Remember my little plant, in a pot, okay, you do it anytime. Two things. Number one, people don't have too much ownership. They're not too worried about basically, this is my baby, don't tell me my baby is ugly. So they don't have that problem. The second thing also that's useful is because basically you just have an emerging architecture at this point, just starting growing, okay? It's a good thing to start thinking of scenarios because the team may not have thought of all these scenarios, kind of opens their minds, okay? Nice way to use ATAM. Next, okay, now we have a very important tool. When you make decisions, it's always a good idea to log them in decision log. Now, Agile teams don't like to document anything. We know that, we better accept it. They don't like to document anything. So what you do is you actually ask them to document in the tool they use. For example, at Travelers, we use GitHub, right? So we document things right into GitHub, okay? So you can use GitHub as well as a log. And guess what? That's less stressful for them, and they actually do that, okay? Next, please.
When you have them documented in the GitHub, like how do you have them label it differently? How do you extract those?
So Git has couple. So you have, for example, you have a wiki in Git. You can use as well. You can just use it as a simple area just to write down. A decision log for us doesn't need to be very complicated. Decision name, description, time. And
okay, so
that's
okay.
it. Simple. I mean, nothing very fancy. And then the trick is now, as your architecture grows, like my plant is growing, okay, you get to a point where you can use checklists. And the trick we use is we actually use the IPMs, our weekly iteration planning meetings, where we typically point stories in those IPMs. That's what IPMs do, right? Well, so we found a little trick. We say, if you want to point stories, it's always good to refresh your memory, and we display the architecture. And at the point we say, okay, so we display the architecture. At this point, we don't even call that, by the way, we're not going to use the A word. That's a trick. We talk about design. This is just a design validation, a design critique, a design anything. And then as you display basically the architecture, you start saying, well, you know what? This may not have been exactly what we wanted. There's a concept of architecture drift. I love the word drift. I'm a sailor myself, and drift is something when you sail, especially in light wind, a lot of current, you learn to respect drift because you end up not going where you actually want to go. So there's going to be a little drift here, okay? So how much of a drift do we have? Okay, is that acceptable? Perhaps it's fine. Okay, we drifted, but in the right direction. Okay, or perhaps we drifted to a rocky shore. So we just start doing something here, or else we're going to find ourselves in the rocks very quickly. So we basically create very quickly some specialized stories, chores, okay, to actually correct the drift. So we actually do validations without being too invasive, and we certainly never use a G word. Anybody knows what a G word is? Come on. Yes, thank you. So we try very hard to govern without governing, which is a key thing, because if you start using G word with Agile teams, you're not going to see very long. They're going to disappear. So that's what's working. And then the last thing, and that kind of goes back to your question, code inspections, okay? We do static analysis with as many tools as we can, and the key is automate, even more automate. That thing should be as automated as possible. Now, I can see a time in the future, I know it's kind of dreaming, where AI will be smart enough that we can actually going to be able to do some of that validation automatically. Okay, we're a bit far from that, but it's possible. I can also see a time when we're all going to be replaced with AI, but that's probably. But this kind of structure works for us. It's nice and continuous. We use 3 techniques. Now, it doesn't mean, for example, you may find out DCAR works better for you initially, and that's fine. But the key thing is go back to utility trees to basically link somehow your decisions with your quality attributes, somehow. There's got to be a reason why you make decisions. So, very useful. Okay, so who validates? It's really, I mean, this is just a point in time. Let's say this is the middle of the process. Because what's going to happen initially? You're probably going to have a large group validating, because initially you don't know what you don't know. So you're going to have a lot of people that need to actually take a look. Some people may be scared, so better take a look at what they are doing, so on and so forth. That's the time, okay. And but here's the trick, okay. So you need a facilitator. Again, one thing you have to remember from this thing, you absolutely need a facilitator. So it's not, you don't need a special person for that, but one of the team members need to be at least trained a little bit on facilitating. If not, what's going to happen, your session is going to become very, very unorganized very quickly. Okay? And it's a good idea to scribe as well, to basically, no special skills, but being able to actually take notes, to actually get a result of this. Okay? So this is typically a facilitator, scribe, and 40 members, could be bigger. As you go along the line of the validations, what's going to happen is the team members are going to start holding each other accountable. So very quickly, the team becomes self-organized, and they actually become self-validating, which is really a nice thing to happen. Okay? They actually hold each other accountable for the architecture, which is, they just don't know it's the architecture, that's fine. Don't need to know. Okay, and of course, structure.
So here's another. So no, you know, I did this quite a lot, and I found this very fascinating. We did this.
You know what Murat does at the
But we went and bought big Lego things, you know, the biggest ones you can buy, which are like this big. And then we also, you can buy like foam shaped things, like also toys, because Lego is at the end of the day just a single shape. So, you know, then you can buy these foam that go to any kids, you know, nursery, you know, thing website, and you can get this. And we actually did this quite successfully for many years of doing architecture reviews using Lego. And initially, I thought we would have to give more structure to how to conduct exercise. Like I would like Lego block means, you know, software component, while a round foamy thing means a database, you know, something to get some consistency. But that quickly fell apart. And what really works best is you bring in the project team and you say, forget everything, all your documentation, describe your architecture. You probably need a room about this size, or maybe half of this room. And then masking tape. You need masking tape. And it was fascinating. First of all, people love it because in work, for a change, rather than sitting around the room or looking at documents, people are actually on the ground. And then they construct, you know, you give them about half an hour to an hour, and then they figure out a way to define their architecture. Then other people, then they present to another group of people, and they say, you know, and it's wonderful. It's a great way of building team spirit, and people actually start walking through the architecture, and you know, the times when, you know, fault tolerance is really demonstrated by someone kicking one of the Lego blocks and it falls down, and they ask the project team, well, how did this happen? So it was actually, and the project team scrambles them, shoves another component in there, whatever they do, but it actually gets people thinking physically, and that's I think people like to be tactile in general, and I think we lose a lot of that in some of our, especially corporate environments. So I found that it has nothing to do with any of the industry standard approaches or something, but it really helps with the communication and collaboration and building up team spirit and things like that. The challenge with that is documenting it, because you can't. If you haven't been in the session, you have no idea. You know, we take pictures, we do this, someone tries to draw a diagram, but you have no idea what was discussed. So it's so it doesn't have corporate memory long-term longevity, but it does build that team spirit, and at least people, you know, if nothing else, they've had a good time at work, you know, and have, you know, played around a little bit.
Can you imagine having a good time doing architecture validation? I'm sorry.
The question was, how long does it take? So I'd say about half a day. Basically, the team needs about an hour to think about it, because first of all, the first part is the team itself. They discuss a lot because they've never done this before. So it actually builds the team communication as well. So they, you know, they start drawing and they start doing, then they take it apart and put it again. And then it takes some, you know, another about half an hour for them to do this explanation. Then it really depends about, you probably have another hour of kicking the blocks around and critiquing it and all that type of stuff. But it was very, very, I found that a very, and my children were very jealous when I told them what I was doing at work.
Okay, another idea I stumbled upon, and that came out of a review we did not so long ago at Travelers, was we tended to use, well, we don't use Lego, we tend to use PowerPoint. Problem PowerPoint, there is has anybody heard of someone called Edward Tufte? Okay, Edward Tufte is an author and a lecturer. He's published some books about visual expressions. If you ever comes in your part of the world, go and listen to him. And he has this expression, which is wonderful. He says the communication value of PowerPoint is about the same as the Pravda and the old USSR. Okay, one way. Okay, you basically, this is what I'm going to tell you. You are the receiving end, and you have no say. Well, that's not exactly the idea of collaboration. So what we said is, why don't we throw away PowerPoint and use a wiki instead? Okay, because a wiki is two-way communication. That's the key thing. So as the session progresses, people can record their questions. People can actually answer the questions as well. People see the impact of the work being done. And actually, if you combine that with Murat's Lego, you can actually, you could put the photos, people see interactively what's going on. Very important. Again, do anything you can to have a two-way conversation so you don't have this kind of us and them. Basically, we are the ones being audited, and they are the ones basically auditing us. Try to avoid that as much as you can. So that's a wiki is really, really important. But if you're going to do that, use it in a validation session. So the beauty of that is GitHub as a wiki as well. So in this case, we actually use CodeFluence, but GitHub as a wiki. So you can actually do the whole thing in one tool. Okay? Okay. Summary and recommendation. The whole point is to ask questions. Okay? I mean, always when I'm in those reviews and see someone silent, I don't like it. Okay? Participation is not optional. You are basically in a validation session, you have to participate and you have to ask questions. Okay? You are there to surface problems, not to offer solutions, please. Okay? There's nothing more infuriating than someone that comes, oh, I'm going to demonstrate I'm the smartest person in the room, so I'm going to tell you how to do it. Well, that turns off the whole session. You lose at this point. Okay? Be kind. Very, very important. Okay? No matter what you do, okay, you're not there to be nasty, to prove it. Be very kind. And then always remember the last one, we never done. Software is absolutely never, never done. Well, at least this presentation is done. Okay.
So this is Q&A. Going back to that one question we have, I don't think I mean, it was interesting because when we thought about this, at least when we wrote in the book, we said there's, quantitative and qualitative ways of validating architectures. And actually, I've realized that in this presentation, we always say do a mixture of those, but all our talk was more on the, really driven on the qualitative side and not any of the executable or the quantitative, except for the mention of, static code analysis tools, etc. So I don't think we sufficiently addressed it. I don't know if there's anything else you want to say on that.
No, actually, again, back to the ATAM class. Initially, if I remember clearly, in the intro, they talk about qualitative method versus quantitative method. The whole class is about qualitative and especially ATAM. The quantitative is actually very, very quickly dealt with. It's not easy, but the whole, at some point, the MDD, the model-driven development, was big. Okay, it has now a little bit of a recess. I think that's what I see. Which is a shame. I think that definitely would be nice if we had a way to take a model and execute that model and test that model. Again, a set of assumptions. Not there yet.
The example I was kind of coming from was, supposing you had a system where it's like, okay, the test itself, if you go out and have to test it in the field, it'll cost you $5 million or something like that. It's like, yeah, I can't really just go out and execute that easily. I need some kind of model that, especially if it's a physics-based system, where there's a lot of, it's not strictly just software. So imagine you need to have a flying plane and you're trying to detect it. Well, there's a lot of cost in doing stuff like that. So if you don't have some model of the system to do it, it becomes very expensive, almost unwieldy.
I agree. Through the years I've been doing that. I came across a lot of companies that came up with, especially, I mean, back around 1990 to 2000, a lot of companies tried to do work on MDD. And so some of us are still the victims of some companies. How many people know, when I'm going to use a term that people may or may not know, how many people know something called CoolGen, which is right now owned by CA, or CAGen? Okay, CAGen was, now I'm really, you know what I'm talking about, right? So CAGen was actually the old IFIW. Now that I'm showing my age, right? IFIW was initially invented. Who came up with that thing? It was Texas Instruments, I think. And it was supposed to create a model, okay? And this was the time of COBOL, of course. Voila, push a magic button, your COBOL code came across, okay? And no risk, because you know what? You generate COBOL code, so you don't like us anymore, no problem, keep COBOL. Only one little problem. No human being I know of could actually read a COBOL, okay? So in fact, you're now forever condemned to use CAGen, which is exactly, so we at Travelers have, I don't know how many millions of lines of code of CAGen, that we no way to get out, and we have to pay CA and upgrade. And Hal, seems like you're the same experience.
Yes, we have seen the same thing. If I might just add another thing, you were talking about experimenting when it has interfaces to the physical world. In Statoil, where I work, we have a research lab where we have big, full-scale models of the control rooms, the drilling decks, and all of these things, which we use for testing software. And that also means that we can continuously validate our architectures by playing with them in our labs. Of course, the labs cost a fortune, but still, it allows us to continuously validate before we deploy.
So this is Q&A. So if there's any, I think we're
questions?
Any other questions?
Yes.
In your definition of architecture, you kind of referenced decisions as a work product as part
Unit
of that.
Work, yes.
Could you elaborate a little bit more about that?
Yeah, no, definitely. It came out from when we have a blog which we update once every other year, but in the days when we didn't used to update it, someone wrote a feedback around. It was a very interesting question. We were talking about architectural decisions, and someone actually, or maybe it was the role of the architect, but asked the question: how do you measure architects? What's their unit of work? You know, because you can measure a software developer. They write code. You can measure a tester. They execute test scripts. What's the unit of work of an architect? It was a great question, and our response to that, and actually the question prompted the response was, if architects do nothing else, they should make architectural decisions. Everything else that an architect does is towards making the decisions that enables, I guess, a coherent product that you're developing. So that's really what was behind that whole thing, is that it's very central to the architecture. So you can draw 0 diagrams, you can have 0 models, etc., but just make sure you make the right decisions at the right time.
I was just curious, culturally, when you guys have worked on this and tried to adopt this across many teams and many their projects, have teams sort of received this as you're coming in and you're policing us, looking for compliance, and I'm looking over our shoulder, making sure we're doing the right thing? Or have they viewed it as a healthy safety net to make sure that an architectural principle or decision was overlooked as they go through that?
So it really depends. Jesus' answer, right? It depends how you basically sell it. The selling is, I can't emphasize it, highlight that enough. The selling of it is the big part. If you sell this as architectural review, nobody's going to like it. Absolutely guaranteed, nobody. The trick is to sell the benefits that this brings, the whole thing. So this is really almost an invisible process. You try to make the process invisible as possible, and here are the benefits you get out of doing that. That's why it's so important to actually have the validation team, which is really the same as the project team. You get to a point of self-validation at the end. You basically get a team validating themselves. And that's, I think, what you actually win. If you start getting stuck on, okay, here's my project team, and here's my, basically, validation team, then go nowhere to us and them. It's hard.
and in my experience, anything imposed gets a natural, antibody reaction. And it's really about going back to architectures, more than 50% communicating and collaborating. If you want to do this in any context, you have to do a sell job, right? You have to sell the idea to your management, to the teams, etc. And in all honesty, my experience is that people originally come, very, like drooped shoulders and, let's just send Joe to that meeting because, but if you can't show value to the team after that, actually, you probably shouldn't be doing this anyway. You don't do architecture validations for any other group's thing. Is for the project to be successful. So it really is about selling the concept idea and then demonstrating that it's valuable to the teams. And then teams do either adopt it and become self-validating some of the techniques, or they come back and they say, can we do another Lego session? So that was other.
Well, you just said that the architecture was for the program, but in reality, what we're seeing more and more is that the enterprise is concerned with the architecture, and that's why a lot of times you see the outside architecture reviews, because this is how you get reusability kind of seeded into the programs, because the programs themselves really don't care much about reusability. What have you seen in terms of your approaches from the organizational level of how to influence the programs through this versus just letting the programs build the best thing they can?
So I'll start. So I was talking to someone where the time was working pivotal, he moved on. And I was talking to him, that was about 2 years ago. And I was asking him, his name is Farhan, I was talking to asking him about reusability. And he looked at me and said, maybe, Pierre, reusability may not be the goal anymore. Interesting thoughts, because, during the years of SOA, we all were looking for reusability, all of us, okay? So the whole idea was we have services that we can reuse and everybody's happy. I don't know, more and more now, it's like you build something for a purpose. And if it happens to be reusable, that's fine, but that's not the goal anymore. I think that reusability may be almost an anti-goal.
But another thing is, we said our first principle was architect products, not
projects.
Or the architecture for projects. And I think at the enterprise level, the best way of getting any reuse, or any, I guess, more than the word reuse, bang for your buck as an enterprise, I'm investing so much in IT, why do I have to reinvest again, is to have a product-centric approach. Then, from an enterprise perspective, you can do two things. One is you can evaluate products against each other, so you can see, do you have competing products within the enterprise? And if you do, then it's a decision. You might let them compete because that's good, or you might actually force them to combine, etc. So if you have a product-centric approach, you can do that at the enterprise. Then you could also do another thing, is you can do an inside of then are those products using consistent technologies or not is another thing. So you could do a separate thing. But I think the product-centric approach is quite important. And I'll give you an example that what we did is we did a big effort of a big review of the 100 top projects in our organization, and that was a huge effort. And it was actually done by taking all the existing architects and using them for the reviews, etc. So it was a huge effort. But as a result of that, what came out was that there was a set of 4 or 5 common, we didn't use the term product at the time, but common enterprise services that could be leveraged, by multiple programs. And then we constructed so we actually changed the focus of those programs. So about 6 of them were selected to, leverage the 4 enterprise services, and that was actively managed. So that's an example. But I think the product-centric approach is the way to go to help address, reusability, or at least a bang for the buck.
One last thing before you cut me off. One last thing, actually, a counter-argument to what I just said, I love to argue with myself all the time, is that if you look at functional service, FAS, but serverless, it's actually based on reusability, which is very interesting. So we keep on kind of oscillating between, should we go for reusability, should we not? I don't know.
Okay. I know that Murat's body is on London time, which means it's about 11:30 p.m. So I think we'll just release them. Next up is the SATURN talks down in the Pikes Peak. Short TED-inspired talks that should be interesting and entertaining. Thank you.
Thank you.